Hey everybody, in this video we're going to talk about how to find trig ratios having two sides. If you can see the triangle, you can see that we have this angle alpha that is right here and this angle beta. In this video we're going to analyze what happens with the trig ratios whenever we have those two angles. Let's start with angle alpha, which is this bottom one. To start with, before we even analyze anything, we're going to complete the sides of the triangle. You know that if you have a right triangle, you can use Pythagoras to find the hypotenuse, right? So let's do that. So using Pythagoras' theorem, we're going to solve for the hypotenuse. So we have the hypotenuse square is equal to the sides squared. So we have 25 plus 9 equals 34. So if I only want to find the side without the square, I just apply the square root, right? So we're going to have the square root of 34. So coming back to my triangle, the hypotenuse is going to be my longest side. And this is going to be the square root of 34. Now, my sides, if I'm talking about this angle alpha right here, this side is going to be called the adjacent side because it is right beside it. This one is going to be called the opposite side because it is opposite of my angle. All right, so let's start with this trig ratios. Sine is defined as opposite over hypotenuse. So let's see, for the opposite, I have a 3, and for the hypotenuse, I have the square root of 34. One of the things we do when we're working with square roots is we rationalize. So we're going to multiply by a 1. And we're going to have 3 square root of 34 over 34. And that's how we usually see this trig ratios whenever we have a square root. The cosine is defined as adjacent over hypotenuse. So my adjacent side, it's going to be 5. My hypotenuse, it's going to be square root of 34. And rationalizing my answer, I will get 5 square root of 34 over 34. So now I already have those two ratios. Now for the tangent is defined as opposite over adjacent. So in this case, my opposite is 3 and my adjacent is 5. So I didn't have to do any rationalizing because I don't have square roots. Now the reciprocals. The reciprocal functions are the inverted functions. So cosecant is defined as 1 over sine. Or if we are talking about opposite, adjacent, and hypotenuse, we just flip them, right? So we would have hypotenuse over opposite. And in this case, the hypotenuse is square root of 34 and the opposite is 3. If you see, we're just flipping the results that we already have. Secant is defined as 1 over cosine, and we would have hypotenuse over adjacent, and we have square root of 34 over 5. And that's my secant. Now for my cotangent, it's going to be 1 over tangent. And I have adjacent over hypotenuse. And in this case, we're going to have a 5 over 3. So that is how we can get the reciprocals having two sides. Now let's do angle beta. For angle beta, I already redrew the information that we had, Now we just have a change of names. This is the information that I want you to remember. So sine, like in the famous Sogatoa, sine is going to be opposite over hypotenuse, opposite over hypotenuse. Cosine, it's going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. The reciprocals, they go hand in hand. So this is the reciprocal of the sine, this is the one of cosine, and this is the one of tangent. So that's the information that we need. Okay, so sine, what do we have? We have opposite. In this case, my opposite changes, right? Because I'm talking about a different angle. The adjacent, it's going to be 3, and the opposite, it's going to be 5. So in this case, I have 5 over the square root of 34. Whenever we have square roots in the bottom, we rationalize them. So square root of 34 over square root of 34 equals 5 square root of 34 over 34. In the case of cosine, we have adjacent, which is a 3, over the hypotenuse, and then we rationalize. Tangent, we won't need rationalizing. Tangent, it's going to be opposite over adjacent. So that's that. Now, cosecant, secant, and cotangent, I'm just going to flip them. I know that this is the reciprocal of this. So I have square root of 34 over 5. The secant is the reciprocal of these. So I'm going to have square root of 34 over 3. And the cotangent, I don't know, let me do a squiggly line. And the cotangent, it's going to be 3 over 5. So that's how we can get the trig ratios having two sides. So if you see, we first find the other side, so the hypotenuse or any of the sides that we're missing. Then we label our triangle depending on the angle that we have, and we label them opposite and adjacent. And then we just set up the trig ratios. So now let's see what happens. What can we say about the ratios for alpha and beta? So that's what we found. If we look here, alpha is this one right here. Beta is this one right here. And this is the information that we did on the past two slides. So what can we see? So we see that for the same triangle, right? The sine is the cosine of the other. The sine is the cosine of the other. The tangent is inverted, right? The tangent is inverted. And we have the same, pattern for cosecant and secant. If you see, they're just inverted. And this one is just inverted. So my triangles, alpha and beta, are actual alpha and beta are complementary. They're complementary angles. They add up to 90 because my other angle is already 90. So that's a cool fact because that actually gives you an identity that we're going to use in the future.